TDL is the development language of Tally ERP9 and thus is a very significant element of Tally technology. There are numerous reasons why TDL is very suitable for development of Tally ERP9. Being a fourth generation high-level language, TDL is basically non-procedural in nature. The entire code is composed of a set of definitions which belong to various categories. It's an object-oriented programming language. Actions in TDL take place based on user interaction. The action can be pressing a button, pressing a key, or selecting a menu item. TDL has got a number of advantages and is endowed with enormous capabilities. The visible elements on the Tally ERP9 user interface are menu, button, table, and report. There are other elements comprising a report, namely form, part, line, and field in a predefined hierarchical order. A menu contains a list of menu items, clicking on which leads to another menu or a report. Buttons are present at the top, on the right, and sometimes also at the bottom of the screen. A button is an action initiator. The name of the report can be seen in the top left corner. A table gives a list of options to choose from while making an entry. The hierarchy of a report starts from the form and ends in the field, which is the container of data. Let us make use of different colors for a part, line, and field to understand the concept better. A form contains a number of parts. A part contains a certain number of lines, and a line contains a number of fields. A part can further contain parts in the hierarchy. A line can further contain lines, and a field can further contain more fields within it. This gives more flexibility to the developer in designing the layout for different kinds of reports. It must be kept in mind that the hierarchy always ends at the field. The Definitions are the basic building blocks of a TDL program. For example, the menu and the report definitions. Each definition is followed by a set of attributes. Modifiers are used to modify the existing definition or attribute. For example, the modifier use helps the programmer to reuse a previous definition. There are various symbols in TDL used for specific purposes. For example, the hash symbol, while reusing an existing definition, and the double semicolon used before a comment. A number of prefixes in TDL act as access specifiers. For example, the $$ prefix to access a function and the @ prefix to access a local formula value. Actions can be used to perform various kinds of functions. For example, the display action is used to display a report. Functions are the procedural components of a TDL program. Consider a basic TDL report consisting of a single field. The set as attribute is used to set the value of the data within the field. If the report consists of a number of parts, lines and fields, the TDL program will be somewhat like this. We can always specify the dimensions for any interface element by making use of dimensional attributes. Let us see how to write a TDL program to modify a menu by adding a menu item which displays a report. The attribute item is used to provide the name of the item to be added to the menu. This is followed by the action display. The name of the report to be displayed is specified as the parameter for the action display. To add a menu item which displays another menu, the action used is menu. Let us see a program which makes use of the modifier use. In this program, there are two fields which have been assigned two different styles for displaying the data by using the style attribute. Two style definitions have been created for the same. The second style definition reuses the first style definition and modifies the value for the height attribute. The other attributes are inherited as present in the first definition. A local formula has been defined in field 1. This value can be accessed in the same field by prefixing the local formula name with @sign. Local formula can be used in the same definition and they are helpful when the same value has to be accessed multiple number of times. System formula are defined under the system formula definition and they can be accessed from any definition by prefixing the system formula name with the @ sign. The name of the variable is declared in the report definition and its initial value is provided using the attribute set. The value of the variable can be accessed by using the double hash prefix. The value of a field can be accessed by prefixing the field's name with the hash sign. In this example, we'll create a button and use it to change the size of the form. The button, along with its name, is declared within the form definition. There are two optional definitions for the form. The form named small form becomes active when the value of the variable is no, while the form named full size form becomes active when the variable's value is yes. In the button definition, the action associated is toggling the variable value from yes to no and vice versa. Thus, whenever the button is pressed, the value of the variable changes and so does the appearance of the report. Hope that you are all set to dive into the depths of TDL.